Okay,
So,
recording's on and transcription's on. You're good to go.
all right. So I have the pull request open in Visual Studio Code because it's kind of a big pull request with a lot of like vector internals that I'll have to go and jump around to. So I figured there's a good one to review here. So looks like it removes some helper functions that are only used in the vector and does something with getAll and cleans up and generalizes the construction of vectors with known size. All right. So starting at the top of vector, we get rid of this function and then immediately see that we're replacing it with this construct n. So we've got, so it used to be count and then a tag. And it would go through and send the tag through to container proxy pointer. There it goes. Unfortunately, the pull request view doesn't do a great job of doing the IntelliSense stuff. That's all right. Allocator. Oh my God. Something else. Sorry. How does this machinery work? So this looks like it's some IDL thing. And it's not. Maybe it's not signed about. Oh, okay. So it constructs this pointer presumably to do IDL and like fancy pointer stuff. And then on fills in from first and then releases the proxy. Okay. So let's go down and look at construct at, which is new, which is what's replaced this for count and size. And how do they get rid of the either we're just passing in count and presumably, yeah, ty comes from the vector, so it's a member function. We probably don't need we don't need to pass the types in, although we do anyway. in some cases, it looks like. So if they're okay. Yeah, no, okay, that's fine. We can use the variadic generics in all of our compile modes. CRT overflow I looked up earlier, and that just expands to something to declspec guard overflow, which tells the compiler to insert an overflow check beforehand, before the call, because it can't be done after the call, because at that point overflows have already happened. So that's neat. And that's on count, and we have those. All right, so we get the allocator through get al. What was that called? What does this expand to?
So this is a particularly weird bit of machinery that makes no sense whatsoever on first sight. What it's intended for is under iterator debug level 1 or 2, which is the else code. It gets the actual allocator, it rebinds it to the proxy object, which is the dynamically allocated object that we use for iterator debug level, and then returns that rebound allocator. So that's what that static cast of the rebind alloc type is doing. And it also provides an alias container proxy putter, which is that RIII guard that you looked at earlier, that can hold an allocated proxy object while we go do other allocations. And if they throw exceptions, then we won't leak the proxy, which is a problem we had in the original implementation when we just had raw pointers. But it's convenient to be able to do this stuff unconditionally, even when we're in release mode, IDL 0. So that's what that IDL 0 code does. We got this empty object called a fake allocator. It's not a standard allocator, has literally no member functions. It's just a placeholder type. Get proxy allocator then returns object of that type. Due to a compiler bug, it's an inline context for used to just be a temporary. And then the container proxy putter becomes an alias to something that doesn't bother to do anything, but is still constructible from this fake allocator and supports the same sort of interface. This is all just to get around having lots and lots of if-defs in the later code.
Okay, that makes sense. And this container proxy putter, like the real one, is this is just a ABI thing?
It's a RAII guard. So it will hold
the numbering.
Oh, the 1, 2. Oh no, this is this unlike the other 1 and 2 suffixes we have. When you see 1, 2 together, it means I'm for IDL 1 and IDL 2.
Okay, yeah, I was gonna say, because if it's for ABI reasons, then I mean,
yeah, how we go up to version 12, like ref count obj 3.
Yeah, I mean, it's just, yeah. Also, it's ugly, so that would be strange. The pull request view has escaped again. Oh, it's because it's not pinned. There we go. All right, so we get the proxy and we get the allocator proxy. Why does it need to be a universal reference here?
It's because the allocator that's being returned is actually typically a temporary because we rebound a copy. So it can't be an L value reference because you can't bind a modifiable L value reference to a temporary. And it can't be a const L value reference because we need to like actually allocate through the thing, and that's not possible for const. So we need to bind a reference to a temporary and hence autoref.
That's, I mean, okay, but that seems to be doing an end run around the value category system. But we'll see. Maybe it'll become clear. All right, and then we get the data. And then we make this container proxy putter, which oh my god, the there we go. Okay, yeah, which we've already figured out and is defined in both modes through that, and we make it with the proxy. Okay, and that's why it can construct that, and the my data, which is yeah, the container base, the presumably some value wrapper of some sort.
Yeah, it's the vector val. What you're seeing here is layers upon layers of machinery to handle optimizations. The my pair is a compressed pair. We're trying to compress away an empty allocator, but we don't have or didn't have the no unique address in CS plus 14 and 17 mode. So we've got to manually implement a compressed pair, and we implement the scary optimization, which is where container iterators don't depend on allocators. So that's why vector, which is templated an allocator, derives from a base class that actually stores its data members that is not templated on allocator.
Okay,
that helps mangled name bloat.
Yeah, that's similar to what format is doing now with making it so that all of the formatting machinery doesn't depend on the output iterator type. So you do a similar thing where you at the top of the line or at the bottom or at the beginning of the call stack you make some derived class that does depend on what you want, and then it's derived from something that doesn't. All right. That's confusing, but that's fine. All right, by non-zero. So, okay. So if we have count, so what do we do if we don't have count? We don't do anything. That's probably good. Why do we bother with all this proxy stuff if we don't have anything to actually insert? Is there some reason that we need to that we need to do that we need to do all this stuff unconditionally? I guess it doesn't really have a cost on IDLO.
The I believe if you look at the proxy release, I think that's the thing that actually installs the proxy into the container.
Right, it would be the real one, not the fake one, wouldn't it?
Yeah.
I
didn't write this myself, so I don't immediately remember how it works. Oh, release just nulls out putter. It's bind that attaches it to the container.
Yeah, I mean, it's all going to get optimized out anyway, but it might be a debug code gen improvement to not do the release. So I don't know.
Perhaps I'm missing where the proxy object actually gets stored in the container. I don't see a bind call. I just see the release.
Yeah. So what was happening in?
Oh wait, this is Misco's new code. It's possible we're actually looking at a bug.
Yes.
I didn't realize that. We're looking at the green side.
Yes. There is only a green side, but let's find. Yeah, here we go. So this is the old code. And we get out, we construct the proxy, we do this. Oh, it might happen in here. God, the naming is very bizarre, honestly, but. All right, so that's the reallocation machinery. Are
you sure you're looking at the main copy of vector and not the branch that's being edited?
Yes, because
Okay.
this function was deleted.
Okay, cool.
In the edit. Tidy guard.
Oh, is it the construction of the container proxy putter that installs it into the container and then the DDoR will delete it if it ended up not being dismissed? That would explain why we're not seeing a bind. Yeah, there it is. It's the second constructor that takes container base 12 ref that stores, that sets the mycontainer.myproxy member. So it's not just floating free. It actually is bound to the container at the time of construction. I didn't realize the constructor had that side effect. Okay, so it's not being like dropped on the floor when count is 0.
Okay. And then delete plain internal. Yeah, but where does it do the release then? Where does it unassign my proxy?
That's in the base class basic container proxy putter 12. That's where that underscore release, it's a dismiss. That sets the destructor to do nothing.
Just this is all that's needed there.
Yep. The idea is that now that I've seen this class, the constructor of the container proxy putter 1.2 constructs the proxy object and allocates it from the allocator and then stores it in the container. That's the mycontainer.myproxy equals putter line on 1323. But the guard object, this container proxy putter 12, also stores a pointer to the allocated thing. And so if an exception is thrown, this guard will delete the proxy object because the container itself will not.
So the
This
container, yeah, the container is borrowing the memory from the guard, and this container proxy putter 12 is actually managing the memory itself. And so when it's released, we say putter equals no pointer, but we don't.
And we've already given the pointer to the container. So now the container, we know the construction is going to succeed and the container assumes ownership of the proxy. The issue is that during the construction of a container, if an exception is thrown, the destructor of the container will not be run. So that's why we need the guard until we're certain that the container constructor is going to succeed.
Okay,
when we know the container will succeed, then the container destructor will destroy the proxy. And
oh, I
everything
see. So
else.
we're constructing a bunch of stuff, and so this is constructing, and then we tell the container, okay, and then we say, and this constructs, right? Okay. That's a weird situation, but all right. And then that's why delete plain internal isn't going to deallocate. Oh.
Yeah, it destroys and deallocates, but with an allocator rather than plain delete, basically.
Oh no, it isn't here. And it destroys. What is it?
So this class is managing only the proxy object.
Yes,
the container itself is going to deal with its like allocated memory.
Yeah. What I'm confused about is why it actually deallocates the memory instead of just calling the destructor, given that it's constructing it in the vector itself. So when the exception,
it's a separate object. It's not related to the constructor's potentially owned elements. This is a different object of a different type, the container proxy type.
Okay.
And the proxy is just an object that basically stores a single pointer, a pointer back to the container itself.
That's pretty confusing.
Yes, it is. This is due to our iterator debug level 2 representation, where iterators need to be able to find their parent containers. And to handle container swaps and moves, where essentially the parent can move around in memory, we need an extra layer of indirection. So that's where this proxy object comes into play, where iterators actually store pointers to the proxy object, and then the proxy stores a back pointer to the parent container. So if we swap or move containers, we need only update the pointers within the proxies, and that will inform all of the children iterators where their parent is in constant time, at the cost of a dynamic memory allocation. In a vNext, I've eradicated this machinery, and the new scheme, which will eventually ship, is that containers store direct pointers to their parents, but if they get swapped or moved, we need to take the debug lock, walk through all of the children, and update all of their parent pointers, which is more costly, but avoids this dynamic allocation, and I suspect may ultimately be less costly, certainly less disruptive.
Okay, so this is just so that when we reallocate containers, the iterators can find them again. And what forms the chain of containers that you have to walk up and down?
It's an intrusively linked list. So the container stores a pointer to its first iterator, and I believe it's called my first iter. And then each iterator stores a pointer to my next iter. So it's a singly linked list rooted at the container from where you can walk through all of the children iterators. And so that's how you can do things like when a vector reallocates with like a pushback, or if it gets selectively invalidated with like a insert or erase in the middle, it can walk through all of its iterators, find just the ones that are affected, and selectively invalidate those. We need to be able to find all the iterators in order to do that. Iterator debug level 1 has a more limited implementation where you can basically invalidate everything or nothing. But although the machinery remains to enable it, it's not really important because nobody actually activates it.
Okay, let's move on. But even so, that means that in debug mode, constructing this container proxy pointer is actually a cost.
Correct, a significant cost.
Yeah, which we might not have to do.
Note that in debug mode, there's a container invariant. Every container needs a proxy. So even if count is 0, what's happening is that this construction installs the allocated proxy in the container, and then proxy release dismisses the proxy, but the container stores ownership. So that's still needed.
Okay. I'll write a note. Okay. So by non-zero count, so that gives us our memory. Tidy guard. And that's fine. Okay, so this is doing the cleanup if there was an exception. Yep, which is why. Yeah, which is why we see this guard.target business. I'm not really sure. Well, that's pre-existing. Whoops.
This was an enhancement that Billy did a while back. Originally, this was all try-catch. That was Dinkamer's original code, which interfered with debugging and had other downsides. So now we get the RAII object to handle any exceptions and avoid leaking memory. And all we need to do is dismiss the guard at the end when we succeed. Tidy is the conventional name for the container cleanup function that's also called by the destructor. But the tidy guard is the new bit that was added.
Yeah, that's what I was gonna ask, is why not just put a try catch in? But I guess then you don't really save any code because you have to write the thing in the catch statement instead of having it pulled in by this object. So, oh well, that's fine then.
Yeah, the try catch was worse in terms of code clarity. So this is an improvement, although you have to go look at the definition of tidy guard when you see it.
Okay, yeah, and it just. All right. Is this allowed in C++ 14 mode? Are we in a C++ 20 only area? This size of parameter pack thing is a relatively recent addition, is it not?
No, it goes back to C++ 11.
Really?
Yeah, as long as there's been parameter packs.
Oh. Thought it was a new addition. Well, that's fine then. And I guess it would have been caught in testing if it like straight up was not valid or was unsupported 14 code. So that's not that bad. All right, this Where does this come from? Okay, it's just a utility function in X memory. And before that, we're using ufill, which came from vector and just did that with a call to, okay, so that's what the getAll stuff is talking about. So this is going to improve debug code gen because it's not going to be getting the allocators separately for each case. Although they're only ever called once for each size, so. But that's fine. Oh, sorry, I forgot the video was on. Don't want to lean into the camera too much. Okay. So in that case, we do the construct NTY business. Make sure the TYs are the same. I guess this seems like it doesn't actually have to be a variadic generic technically, but it doesn't do much harm.
The pack has to be expanded, and in this case, the code is assuming that there's only one element in the pack because of the if context per test. If somehow 2 or 0 elements were in that pack for the is same v, it would fail to compile horribly.
Well, yes, but I mean, if the pack was just like an array instead, it wouldn't. I mean, I guess debug code gen would probably be worse, but you know, the types are all the same. But yeah, here it is expanding, and it has to expand into one. Into one element. Is this the same behavior as? Yeah, it is. It's uninitialized in each case. Uninitialized copy. Why is this working? Is this calling a different uninitialized copy than I'm seeing here?
No, it should be that one. Looks like Misko's using this helper function to pass a first last range when the number of elements in the pack is 2. So that's what the forward val t val is doing.
Oh. Okay, but does that mean that it's copying directly off the stack?
No, it's going to copy a range of elements denoted by the first and last iterators.
Oh, I see. So it's just different behavior.
Yeah, it's kind of weird that for one element, it's make n copies of this thing.
This is a really bizarre function.
Yeah.
He's going way out of his way to crush an overload set into one function template here with if Constructor switching.
Yeah.
I don't know if this level of unclarity is worth the throughput increase potential, but there it is. So
Yeah.
As we're reviewing this, the two things that we need to find are one, at a basic level, is this transformation correct? Which, as you've been stepping through, been seeing, okay, are we, dropping the proxy on the floor? Are we doing all the right things? And the second higher level question, once we've, reviewed all of the PR or a substantial chunk is, okay, because this is a cleanup, it's not a bug fix or, things like that. Is it actually an improvement? Like, is it achieving, either a performance win or a throughput win or a code clarity win? And if it doesn't seem to be improving throughput, and if it's not necessarily clearer, then we shouldn't necessarily accept the PR. Because like change for the sake of change is not useful. I haven't looked at the PR enough to decide if it's better or worse or whatever, but it is interesting. It's certainly the case that because vector was designed before we had access to ifconst.expr, there's certainly ways we could restructure the code. So it's possible that this is an improvement.
Yeah. But this is a confusing bit of code. I'd appreciate some comments on this particular thing. Anyhow, all right. So it's forwarding. So what was Misko's comment here? That it's forwarding user-defined iterators. Oh. Okay. So that means, okay, so that might be part of the motivation to do it this way.
I observed that we could do that still with a separate function.
Yeah, why do we need always false here?
That's to prevent
so
the
that it's
compiler
sure
from eerily evaluating it. It's odd that in the standard, you would love to be able to say static assert false, and then
right,
have
but
that.
That would just always fail because yeah, all right.
Yeah, it's permitted to always fail, and compilers indeed do evaluate it eagerly. So we use the always false template to say, only think about it when you actually instantiate the thing.
Even inside of the const.expr branches of the const.expr ifs?
I believe that's the case. It'll look for ill-formed code, and if it's a straight-up compiler error, it will eagerly diagnose it. And this is the one time you want to tell the compiler, no, be lazy. Like, don't check it yet.
Well, many times, but yeah. All right, so that makes sense. Okay. So that function looks relatively okay. If confusing. And it has replaced this. And I guess it doesn't need to do the value init tag anymore because that's assumed. So we replace it there and there. Range construct or tidy. I'm gonna open just make a note so that we can come back to it later. In the constructor, get was okay. We moved some of the stuff around. So what we were doing before, we were getting the proxy allocator. And then doing that, and then doing range constructor tidy. Range constructor tidy is the third overload there. Okay. Let's see, we've got 2 of these. Okay. And now we have to do a context per branch on whether we're an input iterator or a forward iterator. If we're, can we be neither an input iterator or a forward iterator?
Not for this function, though. The argument has to be at least an input iterator.
And that's okay. Yeah, that's just, yep. All right, that's just a precondition. That's fine.
Yeah.
I think there may be, what if a user has a custom iterator tag that's derived from input iterator and not forward iterator, but is not exactly input iterator? This is asking is same. Is that a potential issue for a elaborate library like Boost or something?
In theory, yes. What were we doing before?
We were using tag dispatch.
Tag dispatching before. Yeah, it should be is derived from.
Yeah. We found a bug.
But it has to, it would have to be restructured a little bit, because if you ask, hey, is base of input iterator tag, that will always activate.
For iterator tags.
Yeah, I can't remember because we have similar checks elsewhere. Do we use is base of or is convertible? Because we do solve this problem elsewhere in a couple
We
of places.
probably use this convertible because we didn't have the derived from concept.
That's right, because it has to be like implicitly convertible, and is base of is kind of weird. It'll actually look it through private inheritance.
Yeah, is base of is almost always the wrong thing.
All right. No,
So-
wait. So shouldn't, I mean, doing is derived from input iterator will, why won't that work? Forward iterator isn't derived from input iterator, right? So
It is derived from input iterator, right? So if you check the input case first, then everything is going to go through that case. Right? The two cases would need to be switched. You check if it's derived from forward iterator tag, and otherwise assume it's derived from input iterator tag.
oh yeah, okay.
You can probably, if you do a an STL-wide search for is convertible .star iterator tag, that may bring up precedent to cite. If you've got the STL loaded as a workspace, it's got to be convertible with an I.
What was it? Input iterator.
You'll want to use a regex. So I'd say is convertible .star iterator tag should bring it up. You've got to click the dot star there. There you go. Oh, and look, we actually have helpers. Ah, okay. This is what I was thinking of. Yeah, so using these helpers is
Yeah, so it should be is forward iterator is convertible from is itercat convertible to the forward iterator tag.
That's right.
Okay. Wait, that's going to exhibit the exact same problem though, right? You still have to reverse the order of the.
Yes, it does need to be reversed, but it will handle cases like unusual libraries in Boost where the tag is not exactly input iterator.
Oh,
but
the
it's certainly not a
standard is the standard is it just has to be convertible. It doesn't have to be derived from, because there's supposed to be tag dispatch on the things.
Yeah.
Should be is, what do we call it? Is input.
No, the other way. It should be is forward iterator.
Well, yeah, but this one should be
So two things need to happen here.
No,
One is
I know.
Yeah.
It or a cores. It's probably still spelled wrong. It's okay. Okay. Again, it seems like, you know, we've removed an overload set to add more if context for branching, but there may yet be a deeper reason for all of this. Oh, okay, and then we just inline the whole function in here. Which okay, so that's doing an uninitialized copy. And here oh, okay, yeah, that makes sense because we actually have to iterate through everything and we can't just copy in one go. If we're not wait, yeah. If we're not a forward iterator, all right. So that's inlining that function. So that's not too egregious in terms of increased code complexity because that version of the overload there just goes away completely.
And for those who are less familiar with the STL iterator strengths than STL maintainers are, the whole reason we're dispatching here is when you have input-only iterators, like from an iStream, you don't know how many elements there are going to be. So the vector cannot reserve or resize a certain amount of space ahead of time. So we have no choice but to individually push back or now in place back elements. But if the user constructs a vector from a range of forward iterators or better, like a singly linked list, a doubly linked list, or just pointers, the vector can count how many elements they're going to be, allocate that much memory in a single chunk, and then fill that memory without repeated allocations. So this is a case where the STL will do the optimal thing if you give us strong iterators, and if you give us very weak input iterators, it'll still compile. It'll be as efficient as possible, but it is less efficient.
Yeah, although do we count linked list elements before the end? I mean, presumably depending on the situation, that could be slower than just doing the repeated pushback, right?
It could be, yes, but we need to traverse the elements no matter what. So a second traversal is probably not terrible. That's happening on line 513 of the new code. It's in the distance call. It is certainly a trade-off, the two traversals versus a single traversal, but repeated reallocations. I believe what tips the scales is that in the repeated reallocation case, every time you reallocate, you also need to traverse the growing vector to copy all of the elements over. So you end up doing a lot of element traversals of the vector itself, and that will destroy any time savings from not traversing the input twice.
Yeah, that makes sense. All right. Yeah, so presumably this count thing, yeah, that's what that's doing. Computing the distance. And then we call that and we move U first. Yeah, we move the unwrapped iterators. Which is fine, I think. Yeah, I mean, we're always going to be copying them on the, okay, that's fine. Then we have more of this. So this is random access iterator tag. Okay, so that gets, yeah, that's going to be this version. We do that, and okay, I like that this consolidates all of the proxy stuff into one function. So that's nice. Perhaps that's yes, and if you have the overload set, then you have to rely on the caller doing that, right? Because otherwise you get multiple proxies.
That's right. You wouldn't want to construct a proxy and then call a function that constructs another proxy. So this does look like a clarity improvement to
Yeah, you could do it.
centralize.
You could do it with like a local class or something. Define a little local struct that that has the operator, uh, the call operators, I suppose. But that's significantly less nice.
Yeah, if you're looking through all this proxy stuff, it really makes you wonder if once we get ASAN powerful enough, if we should just eliminate IDL and say, it's not an exact replacement, but it supersedes a large chunk of the functionality, and it's just simpler to not have all this iterator debugging through.
Yeah. I mean, I definitely we should not we should just store the proxy stuff in like a null pointer in release mode, but
well, there is no proxy in release mode. All this machinery essentially vanishes.
Yes, I know, but that means that the vector is a different size in release mode.
Oh, yeah, and that's intentional. Like if we store just like a null pointer for the proxy, we would be bloating each vector by 8 bytes. So although having a representation change is not great, the representation is essentially different either way. There's no mixing and matching possible, even if the vector were the same size.
Oh, right, because if you happen to get the wrong IDL level, then like all of the proxy invariants would immediately be violated.
Exactly. And in VS 2005, our predecessors tried to do that with basic string. They tried to have a string that could cross between the user code with a different IDL setting and the DLL. And it was an absolute nightmare, and it never worked perfectly and had to be eradicated in 2008.
Yeah, you'd have to basically do like type erase the whole thing and do everything through virtual function calls, which would be not good. Very not good. Much slow. Okay, so now we've got this one. This is what were these? Right, initializer list constructor, that looks fine. Copy constructor. My pair, my val. Pull out the data in a const manner. Construct that. Oh, and then immediately do by raw. Why did this do by raw and not the other function by non-zero? Oh, because it might be 0. And then x length. Okay. Oh, that's just if it's massive. These names. Where did these names come from? Like historically.
The by and tidy are Dinkelmer conventions. By is an allocation function. Tidy is the cleanup function. The other stuff here, like change array, those are later enhancements by Microsoft.
Yeah, well, I was thinking even earlier than that, but anyway. Okay, so we do the uninitialized copy. And we took our .target. And here instead, we get the count. That's gonna be, does this make debug code gen worse? Since we're, oh no, it doesn't. We're going through the data, not through the actual iterators. That's fine. I was thinking if this was subtracting the vectors iterators, then perhaps that would have badness in debug mode. Yeah, that looks mostly fine. Let's see. With an allocator.
And these two functions are, these are a good example of how this could be a cleanup, because the immense duplication between these two very similar constructors is now being unified. So this is very nice to see.
Yes, this is the motivation and is why, probably why, well, okay, what happens to allocator here?
I think if you close the search pane, you might get a little more horizontal space.
Yeah, that's a good point. Oh, it just goes into, yeah, it just goes into my pair. And it still goes into my pair, so that's fine. I observe that you could kill off even this stuff by like having construct n take a vector or something, but that's going a little overboard, I think. Okay, now we have move construct, which we got rid of. Does take contents. So true move construct, true type and false type. Okay, we'll come back to that. And we've pretty much addressed range constructor tidy. Okay, the R value versions. It must have shadowed. That's fine. All right, we do the get out up here. As opposed to move construct, doing it in the move construct. Then we make our, so this is an inline. This is inlining directly. And if the allocator is always equal, that means the allocator is not stateful, right?
That's correct. Or the allocator has state, but the state doesn't participate in equality. Because we can always ask is empty, but is empty is not a perfect
can we make
answer,
a new one?
So it's the default.
Can we make a new one and use it instead?
Allocators are not necessarily default constructible, which is an old bug that we spent a long time squashing.
Okay, so
just because the user has given us the type, we actually need an object, because we can't just default construct an allocator whenever we want.
Okay, yeah, so, but we're moving from one to the other. So that means, so they're not always equal. So it is stateful, and the state does participate in equality. So if the allocator from is not equal to ours, okay, then write data. All right, write first and write last. So we're moving that up. My last minus my first. Great. If first is not equal to last is equivalent to if count is not equal to 0, then by raw tidy guard my data uninitialized move kind of just a stylistic refactor here, but I'm okay with it. It looks equivalent. Uninitialized move. I just uses okay. What did uMove do? I really wish I could go to definition from there. I wonder if that's a bug in the, or a missing feature. Oh. Yeah, this is better. Okay, great. Yeah. Okay, and then where does proxy come from? Up here, okay. This could just be an else branch, couldn't it?
No, because this is a hybrid of an if const expr and then a runtime
Oh yeah, you're
if.
right. Okay,
And sometimes the runtime if, yeah.
Okay, yeah. So if they are equal, if the allocators are equal, then we just steal the guts. Oh well. That's weird, but fine, I think. And then we release the proxy in either case. Great. Okay. Now we've got the copy. Right, so before that was calling move construct, and it was causing, yep, and it was just tag dispatching on move construct. So that's both of those move construct calls were used. Move assign, presumably that's going to be from here, where we used to, oh my god. No, except, ugh. No, except choose. Okay, returns an attempt to properly allocate is necessary in a move. Assignment operations. Note when false. Okay. Allocated. Okay, great. Self-assignment. Still there. What did we do in the past for that? Okay, we just flipped the condition here. That's fine. If our allocators are equal, so this context per branch up here is just avoiding a pointless equality comparison, or is it that if your allocators are always equal, you don't even have to define equality?
It's purely an optimization. Allocators must always provide equality.
Okay, so it's just to not do this if at runtime. That makes sense.
Yeah, it's very likely that the optimizer will notice, hey, this thing always just returns true, and then eliminate all of the code. But it's a minor throughput win. I guess the biggest advantage is that std allocator is an example of an always equal allocator. So in the vast majority of compilations, we can just discard that.
Yeah, and we don't have to worry about like the compiler. Yeah, about what Casey said. You know, debug code gen.
Yeah, debug. We get the if context for running, but there's no optimizer.
A single additional if statement in debug code gen. Well, an if statement and the call to the equality operator that returns true is not the slowest thing we're doing in debug mode in Vector.
That's true, but note that we also get to avoid actually emitting all of the code below, even if it's never actually executed in debug mode, that will not appear in the final object at all. And that is a space
code size win, yeah. Code size win. Yep, that's fair. All right. Okay, so we check if we're equal. If the allocators are equal, we're moving from the vector. We clean ourselves up. Which we didn't have to do there because we didn't have anything to clean up. And we call Pacma to propagate the allocator if needed. And so that's where the no except comes from, right? Because that means that this is no except.
It's actually Pacma can never throw exceptions because it assigns allocators. But if the allocators have told us not to propagate, then in general, we need to allocate memory during this move assignment, and that's where the exception comes from.
Oh, okay, yeah. I don't understand why this. So, but the exception in the Pacma in the propagating allocators case comes from here, right?
No, it's the no propagation case that can throw exceptions, and that comes from the vector allocating memory. The design of this propagation thing is kind of weird. I think there's only actually one customer of it.
Yeah, but
it's where a vector can, or sorry, it's where an allocator can say, I'm stateful, and I'm going to construct various vectors with different allocators that compare not equal. And when you assign the vectors, I do not want you to assign the allocators within. It's that assigning the allocator within that's referred to as propagation. So if you're move assigning a vector, but you're not allowed to assign the allocator, that means that they can't deallocate each other's allocations, and you need to actually allocate some fresh memory, even if you move the elements within. And that's where the exception can come from.
Okay. Okay, but we can always, since they're equal, we can always just move them from, this move can't throw. Okay, that makes sense. And then we steal the guts. Otherwise, God. Move assign unequal alloc. That's presumably a new function somewhere. Let's go find that. Oh, maybe not. Oh no, it's down here, isn't it? Yeah. All right, we'll get to that later. And see what else is in store, because also reviewing whether it's handling POCMA and allocated propagation correctly is something that I'm not 100% qualified to do, because they're very confusing and I can't keep the different modes straight. All right, so that's another inline of that. This you move if no except. That's going to be yeah, this is better. That's even a rather gnarly tag dispatch situation there. This is better. In my opinion.
I do observe one thing. Can you scroll up a little bit? Look at line 645. Although the implementation of you move if no except has been properly inlined, there's an opportunity to use the bound result of get al.
It's a good observation.
This is something we started doing when we started paying more attention to debug code gen. This occurs like, I think, 6 or so times in the function. So I think maybe just one comment or 5 of them. One comment's probably good.
Yeah, right. Yeah, well, okay, I'll delete this comment then, so I don't have to do all the other ones. Yeah, cool. All right. Then we
It might be worth mentioning to Misco that it does occur 5 times.
Oh yeah.
Just to avoid confusion.
One, 2, 3, 4. Oh. Huh. There may be some reason why we can't use it again, because they did it for insert. It
looks like for insert, Misco was newly introducing al, but in the previous function, it was already there and just missed the opportunity to use it. Very easy to miss.
All right, you fill. You move if no except. Same deal. Where pointer, old last, new vec plus where off, plus count. Allocator, destroy range. The allocator, allocate dot deallocate temp storage you move and old last minus count, old last, where old last, my last, old last, count minus affected elements, temp allocator. New capacity, uninitialized copy, first, last, new vec, wear off. Same deal. Old first, old last, new vec. Old first, old last, new vec. Old first, where pointer, new vec. Pointer, old last, new vec, where off count al. First, last, capacity, my last, old last count, old last, where pointer, first, last, where, count, pointer. You know what? Going through all these is probably not super interesting for everybody watching.
Well, also, if you observe the sub highlighting, you can see when the al parameters are being added. So it's only when like a line is being duplicated, like the splitting of you move if no accept, where the whole line shows up as green, that needs to be carefully audited. But for these ones where the change is restricted to just changing you move to uninitialized move and like adding an al, you don't even need to compare the individual parameters because they're not sub highlighted.
That's a good tip. Yep, we don't have an allocator there. Add one. Like this one. Okay. So appended last. If they're the same, if ty1 and 2, if ty and ty2 are the same type, other than uninitialized fill in, otherwise value construct. And the uninitialized move is first, last, new vec, and allocator. Destroy range. That again, and old last, new size, minus old size. Val. Huh. Okay. Uninitializer first, last, new vec out. Destroy range, destroy range. No allocators, no allocators. And then this is all the stuff that, all the ufill stuff that we got rid of. Eradicate some dinkum comments as well. Get the allocator, destroy it. My n minus my first. Destroy my first. Yeah. Oh, that's just that highlighting. Okay. So we're through all those. Oh, whoops. And now we have to look at this move assign unequal alloc. Let's bring up, I'm gonna minimize this side and bring up the old vector here. Right, that's because it was called something different before it was removed. Which I now can't see because I made it small. Okay, move assign. Oh, look at that. Okay. um, what was the one that was IDL loadout?
I think you just had it there. Was the no propagate allocators case?
Yeah, this one. Okay, equal allocators, propagate allocators, and no propagate allocators. That's just an overload. Maybe those disappeared when things were inlined. I don't know. Or maybe vector ty alloc. Oh, they're vector bool stuff. Okay. And they weren't deleted in this PR. So no propagate allocators, move assign unequal allocators.
So one tip I have for reviewing is when the diff is not cooperative because here the code's being added to a different place. But if the code looks structurally very similar, which does appear to be the case here, like we got the same copy mem move below and all that, copying the old code, the function from the old code into a fresh editor tab, and then the function from the new code, and then directly diffing them can often make it much easier to review rather than visually comparing and possibly missing something that changed.
That's a good idea. Let's do that. Find. Whoops. Hey. I don't want deck. I want to. Is that the right parenthesis or curly brace? Yep. Where is the compare windows button?
If you open up the list of files on the left-hand side, the one that's highlighted with 2, you can compare the 2 editors from here. You can select the first editor, say select for compare, and then select the second, and then say compare selected. Yep, there we go. And the diff is quite nice to look at.
Excellent. There's some get diff, like you can change get's diffing mode, and sometimes it'll pick up on this stuff. But okay, so the no acceptness has been strengthened. But that's okay. I think it was just being enforced earlier on before. Okay. So if al equals get al, If we're in this is a new code. Okay. If we're in proper, okay. Where did that come from? VSO 466800. Okay. There we go. So tidy. And then
I think the second one you're looking at was the vector bool occurrence. I think the first one is the one that's being fused into this function.
it's this one.
I think you're looking at the vector bool occurrence there. Oh no, sorry, you're up high. I'm not sure which one you're looking at. I think the first occurrence of the bug number was the one that's being fused though.
All right, we're gonna get yet another window. Let's get rid of this window. We can't get rid of that completely. All right, but this is where one of those wide monitors would come in real handy, but oh well.
You can move the split to the bottom though.
That's true. Thanks, VS Code. That wasn't. Oh, well, there we go. Anyhow, so we get the allocator first, and then we check. Okay, so it's only called for unequal allocators. Great. So that immediately lets us elide this check. And then we check if it's propagate allocators, which gets us into this function where we tidy. And then we check if we don't have to do this check. We know it's true. And then we reload it. We reload the thing, and then we, if we're in IDLO, and we Pacma. Didn't we just al equals, okay, it's the other allocator. I mean, we could pull that out, right? If we wanted to.
Yeah, if we're referring to write get al twice, that can be extracted.
Yeah, I don't, since it's only twice, I don't care all that much. Right, but
yeah, it's also a very uncommon case to have the non-equal allocators, like std allocator will never activate this.
Yeah, and so be inside the, yeah, I don't care that much. I'm not gonna comment. You can comment if you care more than I do.
Okay.
Then we take the contents, mypair2.myval2. Okay. And otherwise, so that's if we're not propagate allocators. Then we just do exactly the same, except, okay. So you move, and that looks good. An allocator was pulled out up there. And then this code review add-on is really good. Back down.
Yeah, especially because you can see like the whole context of the file, which the web view does not give you.
Yeah, and it's just easier to move around in a lot of cases. And it's all graphical. It's a good demonstration of the benefits that you get from like having your editor be a web browser. I'm sure the Monaco team would take issue with that statement. Let's see. So it replaced this stuff up here. So move assign with equal allocators and propagate, and then no propagate. And we inlined it. Okay. So that looks like a correct transformation of code. What were my comments? Yeah, so basically just that get out change. Oh, and this is an actual bug.
And I can't remember if we have any examples in the test suite of unusual user-defined iterator tags. I am vaguely aware that Boost has a couple of them. And
Yeah.
we added the whole is for it iter v infrastructure to handle them.
We should,
but I don't know if we have like pre-baked iterators.
Certainly just doing the is input iterate or the is input iterator change here and not switching the order should trigger a test failure.
Correct. Yeah, that should. Well, that would not necessarily trigger a test failure because the in place back loop is valid. It's just way more work and doesn't meet the standards complexity requirement. It would be actually pretty difficult for a test to sense that. We could make one, counting allocations, but that would actually be a case of a bug that would not necessarily be expected.
Give us what are they called? Weak symbols, where the test can like define a strong in place back that will fail. I think that's how you do it on Linux. You would, I mean, honestly, I think what I would do is I would define, like I would just type out the mangled name of what this in place back should be and have it cause an error in the test, but yeah. All right, so then looking at this function, I mean, the only transformation that would make this work and still be an overload set without having to push out the container proxy pointer stuff is to have it like construct an overload set in a struct or use like overloaded, which is inefficient from a throughput perspective. But yeah, I don't know what we want to do. I don't have a huge problem with this, but I'd really like a comment here.
I agree. A comment about the n equals 2 case. I think that's the one that's interesting because like the n equals 0 and n equals 1 cases are unsurprising. The usage looks fine. It's like you're saying construct n.
I'd like a comment that basically says we're doing this or we're doing this instead of an overload set because we can't, like, you have to only ever construct one container proxy pointer. And if you do an overload set, then you can't pull that into the overload set, you know? Well, except that you could. The overload set could just be this part.
Yeah, dispatch, but
it would be, well, no, you wouldn't even have to do any tag dispatch. You just call this, right, as a separate set of functions. You get to deduplicate the tidy guard, I guess. But yeah. Is there any precedent for this sort of thing?
This specifically the n equals 2 case is the one that's unusual. The 0 and 1 are fairly common to special case, that sort of thing. Saying, yeah, we're going to construct from nothing or construct from an actual object. But it's the n equal 2 case where instead of an element, you're getting an iterator pair. That's unusual. It's not wrong, and it makes sense in context, but a comment that what the usage is expected to be, I think that would be useful. Because we're sort of inventing a new interface here. Oh, and time check, we are at the end of our time slot.
Yeah, well, we're right about at the end of the review as well. So I think with those revisions, I liked these changes. They look correct to me. They don't appear to cause any problems with ABI or anything like that. And they definitely simplify things and make debug code gen better. And in general, I like inlining code. I think it's frequently a good exercise and can result in you realizing that you were doing things that you didn't need to be doing. So yeah, makes things a lot easier to read. But yeah, okay, so let's go to the description. Oh, I have the batched. I think it's under here somewhere. And request changes, there we go. And that should show up somewhere in the pull requests.
It's one of the older ones, I think. We're trying to reduce our PR backlog.
Yes.
Yeah, 1771.
Yep, there it is. All right, great. Thanks for coming, everybody. Thanks, STL, for explaining some of the container machinery. Hopefully I'll remember how all of that works, at least vaguely. I know Billy has explained some of the details of iterator debug levels to me before. I'm sure. Yeah.
Yeah,
But-
they started. It was a cool seeing how this code's being cleaned up, because I wrote the overhaul here a few years ago, but we did not have if context for unconditionally available at the time, hence all the tag dispatch that was retained.
Yeah.
Okay, I'll go ahead and stop the transcription and stop the recording.
Yeah, this sort of structure kind of illustrates how the overlap between variadic generics like this and like actual macros, you know, like,
Yeah.
they start to converge a little bit.